So good morning to all. Myself Preeti from RMD Engineering College. So today we will talk about variable resistance transducer. So a resistance which is being varied in the transducer, we call it as a variable resistance transducer. So the introduction is the transducer based upon the principle of variation that is taken place in the resistance are generally termed as resistance transducer. So most of this variable it will be depending upon the factors like force, temperature, acceleration, displacement, etc. So there are examples of resistance transducer. When there is a change in the temperature, we call that as it is because of a change that happens in the resistance. Okay. So in a copper wire, and this effect could be used to convert a temperature into an electrical output. Similarly, the same way it can be used for pressure, it can be used for force, vibrations, or anything like this. Now, the principle of resistance transducer will be the resistance of a length of a metallic wire. If you just take a thin metallic wire, it consists of a resistance, okay, R, which is calculated with the formula rho L by A. Whereas this rho is nothing but the resistivity of the material in ohm meter, and L is the length of the wire and A is the area of the wire in meter square. So this is going to be the principle of resistance of transducer, R equal to rho L by A. Now, there are some examples of resistance transducer, which is very important. So, the five examples are potentiometer, resistance temperature detector, strain gauge, thermistor, and anemometers. Now, we'll see potentiometer. So, potentiometer, it is a very simple resistive sensor. It will be like a small knob. The potentiometer will be looking like a very small knob, and it completely depends upon theory of resistivity. Okay, it depends upon the theory of resistivity. That's why we can tell it like it is an example of variable resistance transducer also. So the resistivity is the electrical resistance measure for any material having uniform cross-sectional area. So the resistance of a material depends upon the following factors, which is going to be length, cross-sectional area, resistivity, temperature, and composition. So usually a potentiometer it is a electromechanical device containing a wiper. A wiper will be there. The wiper it is actually used for deflection. It acts like a movable linkage. Okay, so the wiper and the resistive surface it will form like a voltage divider circuit for the whole potentiometer. So the material is used for manufacturing that particular wiper, because wiper plays a major role in the potentiometer, and the material used for manufacturing this wiper will be beryllium and phosphor bronze. So I've just put the picture also here. This is beryllium and this is phosphor bronze. So the potentiometer, it can be also linear or sliding. So the next type of pure pots, that is nothing but potentiometer, is one in which the wiper slides over a straight or resistor strip. So when we talk about potentiometer, you should be very careful that a potentiometer will be having a wiper, and the wiper is made up of beryllium and phosphor bronze. So this you can see, this is the wiper, this is a linear or sliding potentiometer, and this is the resistive strip. So whenever the movement of the wiper moves from this point to from this point, the resistive strips will be producing the variations in the resistance. Right? So this is linear sliding potentiometer. Thank you.